Guys. Okay, I never know what to do at the beginning. So now we're going to kind of get into the meat of probability. It's going to get a little bit harder. You can totally do this. All right, we talked about mutually exclusive events, so events that cannot occur at the same time. And now we're going to get into independent and then dependent events. And so an independent event is two or more things where the probability of the second event does not affect the probability of the first event, or the probability of the first event does not affect the probability of the second event. So for example, if you're rolling a die and you get a 6, and then you roll a die and get a 3, those don't affect each other unless like the dice is loaded. Or like you're drawing cards and you get a queen, you put card back, and then you draw another card and get a queen. Those are independent events. For an example of a dependent event might be like drawing a card, getting a queen, not putting the card back, and then drawing another card. So when they're independent, if you see the word and, you're going to multiply. So we're going to build upon that idea now. Okay. So a coin is flipped, and then the dice is rolled. And remember, it's always a 6-sided die, unless it specifically says, hey, this is a 10-sided die, or this is a 12-sided die. Okay, and a dice is just, a cubic figure with the numbers on it. So if it's 6 sides, it goes up to 6 dots. And so the probability of getting a head on the coin, so that's 1/2, and then a 4 on the dice. That happens 1 out of 6 times. And we have the word and, so that means we're going to multiply. You can, 1 times 1 is 1, 2 times 6 is 12, and so we get 1/12. Or we're going to get into more complicated fractions, and so you can stick it in your calculator, but just make sure you put parentheses around that fraction or it's not going to work. And then you push math, enter, enter, and so we get 1/12. And so that was simple numbers, and my girls right there. It was simple numbers, but we're going to get to ones that are more complicated, and so you may want to use your calculator. All right. So if it's replaced, that's independent. If it's not replaced, then they are dependent on each other. All right, so a card is drawn from a deck, it's replaced, and a second card is drawn. So first we want a queen, and then we want an ace. So there are 4 queens, and 52 total. We have the word and, that means to multiply. And then we're putting that card back, so we still have 52 cards to choose from, and then there are 4 aces. And so you can go ahead and do 4 times 4, and then 52 times 52, or I'm actually going to stick to my calculator. And so we get 1 over 169. $27.04. So 16 right here. Okay, and it reduces to 1 over 69. 1 over 169. Okay, and so I'm fine with you showing what you're doing right here, and then you showing the answer because you used your resource wisely. Like that's the purpose of the calculator, is to do some of these calculations faster than we can, as long as you understand the process behind it. All right, so now we're going to draw a card. We're not going to put it back, and we're going to draw a second card. And so remember, probability is what you want over what you have, or the total. So we want a queen still, and then an ace. So in the first deck, we have 52 cards. There's 4 queens. We're going to pull out, and we get a queen. So when we pull out one card, we don't have 52 cards anymore. We have 51 cards. And we took a queen out, but it didn't affect the aces. So we have 16 over 2652. And so 26, there we go, 52. And so that reduces to 4/663. That's the probability, which is 0.6%. Right, a Harris poll found that 46% of Americans say they suffer stress at least once a week. 3 people are selected and find the probability that all 3 will say they suffer stress once a week. So another way to ask this problem is person 1 suffers stress and person 2 suffers stress and person 3 suffers stress. And the word and means to multiply. And so 46% as a decimal is 0.46. So we have 0.46 times 0.46 times 0.46. And so I'm going to stick that in my calculator. And so I get 0.097336. And so this was a percent, so I need to change that to a percent. And I get 9.7%. All right, so the general rule when rounding is this is a whole number, so we need to go 1 less. And so that's why I went to the tenths and I didn't go any further. That's the rule for rounding in statistics or in math, really. All right, so dependence events is things that depend on each other. So we don't replace a card when we pull it out, or if you're a lifeguard, your probability of getting a sunburn is higher, or you park in a no parking zone and you get a ticket. Those are dependent. All right, so we're going to do this as if we don't replace, and we want 3 jacks. So that's the first jack, second jack, third jack, and this means jack, and a jack, and a jack. All right, there are 4 jacks, and then I pull 1 out, and then I get 3 jacks, and I pull 1 out, and I get 2 jacks. And so the total that I have is 52. Then I pull a card out, so now I have 51. Then I pull a card out, and then I have 50. So in my calculator, I'm going to type those fractions in. Okay, always on fractions, do parentheses. Okay, or you could type it in as with the multiplication sign, it's still going to give you the same answer. 0.1 times, and then that means 10 to the negative 4th. So I'm going to write that down. Actually, I need a fraction, so I'm going to push math, enter, enter. Not going to change. Right, so I get 1.81 times 10 to the 4th. That means we go 1, 1, 2, 3, 4. So I have 1, 2, 1 is the decimal. If you wanted to change it to a percent, it would be 0.01%, which is why 3 of a kind is hard to get in poker. If you wanted a fraction, then we would do 4 times 3 times 2, and we get 24. And then we do 52 times 51 times 50, and we get 13260. 0. We still get this number when we divide those out. So I would write like, hey, write it as a fraction, or write it as a decimal, or write it as a percent. But all these right here, all these 3 numbers are equal. All right, now we want an ace, king, and a queen. Okay, so we have an ace and a king and a queen. Ace, king, queen. All right, when we first do it, we have 52 cards. Then we take 1 out, 51 cards. We take another 1 out. We have 50 cards. All right, the ace, there's 4 of them. We take an ace out, but it doesn't affect the number of kings. So we still have 4 kings. We take a king out, but it doesn't affect, I don't know why I wrote 2, silly. But it doesn't affect the number of queens. So I have 4. All right, I can type all that in my calculator at one time. Or I can do it individually, like 4 times 4 times 4. And then this bottom is 260. I am totally happy with that as our fraction. It's not a huge deal that you reduce it. It does reduce 16 over 5. Okay, and then if you typed it in as one thing, you would get 4. Come on, 4.83 times 10 to the negative 4. And so if we wanted to change that to a decimal, we would go 1, 2, 3, 4, 0.3. So that's the decimal. And if we wanted to change, so the decimal's right there. If we wanted to change that to a percentage, we would get 0.0483. So it's less than 1% chance of getting those 3 cards in that order. All right, let's try a club, spade, and a heart. Okay, you don't put the card back. 52. We don't put the card back. 51, silly. 50. We want a club. There are 13 of them. We want a spade. There are 13 of them. If I pull out a club, it doesn't affect the number of spades. If I pull out a club and a spade, it doesn't affect the number of hearts. So, I'm going to stay in fraction world instead of switching all that over. 0. And then 13 times 13. I get 2197. Okay. And you don't have to stress about putting that in a decimal. All right, 3 clubs. So we get a club, and a club, and a club. On the bottom is always the total. We get a club. We pull one club out, or we pull one card out. So we have 51 left. We pull another card out. We have 50 left. And then we have a club. So there are 13 clubs. We pull one club out, and now we have 12 clubs. Pull one club out, now we have 11 clubs. Okay, this reduces. It's not that big of a deal. Reduce that. All right, let's do this problem as if we're replacing and then not replacing. So there is 3 red balls, 2 purple, and 5 white. That's 10 total. Okay, we want a purple ball and a purple ball. So there's 10. We put the ball back, there's still 10. I get a purple ball, I put it back, and I get another purple ball. So we get 4 over 100. You can reduce it, I'm not going to. You get a purple ball and a white ball. So there's 10. I'm putting the ball back, so I still have 10 balls. There are 2 purple balls and 5 white balls. I get 10 over 100. Get 1/10. And then a red and a purple. Numbers. Right, red and purple. So there's 2 purples, and there are 3 reds. Get 6 over 100. Now if we did it, then we would have 10 balls and 9 balls. We'd have 2 purples. So we get 2 over 90. It reduces to 1 over 45. This one would be 2, 5, 10, and 9. We get 10 over 90. And then this one is 3 over 10, 9. 6 over